with this. Let's go back and talk about the first one I started this section with. First one I did implicit differentiation. It was x squared plus y squared was equal to 25, the circle one. I found that dy dx was, what was it, minus x over y? That was by implicit differentiation. I think I spelled that right. That's what I got. Let's do this the other way, because this one we can. The others, not so much, but let's find the derivative, y prime or dy dx, whatever you want to call it, by solving explicitly for y. In other words, let's do this one the old-fashioned way, the old way. And that is by solving explicitly for y. Do you see what I mean by? So I've got x squared plus y squared equals 25. To use our old method of derivatives, what I have to do is I have to get it down to where I have a y equals equation. That's what I need to do to use the old derivative methods, the methods we've already talked about previously. How am I going to do that here? Well, wouldn't it mean minus the x squared both sides? So you get y squared equals 25 minus x squared. Now I need y equals by itself, so how am I going to get rid of the square? How about we square root both sides? What's the catch though? I got a plus and a minus, yeah. See, y actually is two parts. There's two parts to the y. You got y equals the square root of 25 minus x squared, and you got y equals minus. Do you know what's the difference here? What is y equals the square root of 25 minus x squared? What part of the graph is that? Isn't that the top part? And then y equals minus the square root of 25 minus x squared is the bottom part. That semicircle on the bottom. Just FYI. So you got to have two parts to get y explicitly in terms of x. And that's what you run into a lot. Multiple parts. That's why we usually don't want to do them these way. Do them implicitly. Okay? So now, though, once we have y explicitly, so this is y explicitly in terms of x. Now I can do the derivative, right? And how am I going to do the derivative of that? Well, to do the derivative of that, don't I have to say it's plus or minus 25 minus x squared to the 1/2? Does that ring a bell? How do I do the derivative of that? What rule? Isn't that chain rule? Chain rule, okay. Now it's just chain rule, all right? So I'm going to have plus or minus by the chain rule be 1/2 times, bring the power down, so it'll be 25 minus x squared. The inside stays the same. This is the outside. This is the inside. So I'm doing the derivative of the outside. So bring down the outside power. Then be 25 minus x squared to what power? Subtract 1 from that power. Negative 1/2. Then I'd have to multiply that by the derivative of the inside. What's the derivative of the inside? Derivative of that's 0, derivative of that's negative 2x. You see what happens here? That's the derivative. However, do you see, do a little simplifying here. The 1/2, the 2, and then the 2 there are going to cancel. So we'll wind up with y equals plus or minus, and then let's do this. Let's say that's negative x over this minus 1/2 flips it over, and so the square root goes down there. Doesn't it? Isn't that another alternative way we can write this? We can write it this. But let me do this. And because that plus or minus can go in. What is this? Isn't that y? So this is negative x over y. What do we have before? Negative x over y. Okay? It's the same thing. Now that's an easy one, comparatively speaking, to the other ones. Which way would you prefer to do it? Remember this way, we just, remember it was just, we did 2x, derivative of that's 2x, derivative of that's 2y, dy dx equals 0. We moved the 2x, subtracted it, then divided off the 2y. 2's cancel. Which way would you rather do this one? I think most people would say this way. Okay. You can do some of them this way, not a whole lot of them. I didn't explicitly. But the point is, you get the same answer either way you go. And a lot of times, you can't do even explicitly, but you do get the same answer. You will get the same answer.